right?
Yes.
And our first experiment, we are saying we're using what? Existing tubing. So the requirements, you should have existing tubing, you should have a thread, you should have the digger, you should have the steam water, and our solution that we are saying we're using is what? Sugar solution, which will be a hypertonic solution. Our distilled water will be? Water will always be hypertonic, it can never change. Is that clear? Then now you do what? You tie up a thread. That is that rope that you're given, right? Yes, a string, just a string of this kind. And you ensure you tie it tightly, right? Yes. To avoid any leakage. Then you pour what? Your sugar solution halfway. Then after that you do what? You again tie up a section, then you use another thread that can be what? Left outside this big one. Then you do your experiment for how long? Approximately 30 minutes. This is a practical question, right? It will be a academic question. So you leave it for around 30 minutes so that osmosis can will have taken place with that time. And now I'm saying the kind of the questions that you'll experience from this point is you identify the physiological process. And we're saying our physiological process will be what?
Osmosis.
Osmosis, right?
Yes.
And it should be correct. Osmosis. If it will be wrong, I've said it will interfere and the other section will be wrong, even if they are correct. Then the second thing is observations. Second thing is what? Observations after 30 minutes. Observations after what?
30 minutes.
30 minutes. We have observation and we have accounting for observation, right? Observation is what you see. Accounting is an explanation of what you have seen. Yes. Is that clear? Yes. So what do we observe here? The biscuit chipping will do what? Will increase on swell. It will increase in size and do what? Swell. Then what happens about the level of the distilled water? I've said our first observation is what? This skin. Constants in the biscuit chipping. Or just to speak about the biscuit chipping does what? Increase. Is it increasing in size? Increase in volume. And does what? And swell. Why is it swelling? It will update some water, right? Yes. Then number 2, we are saying water volume. In bigger does what? It will decrease. Why is it decreasing? Because the water is the one that has moved from this point to the inside of the digger, right? That is your observation. Let's now account for those observations. We are accounting for what? For the observation. We account for the observation. Account for what? For the observations. So we are giving a reason. And on accounting of observation, let's see here very carefully. We'll have some 3 areas that you have to understand. The first one is the nature of the solution, right?
Yes.
One has to be hypertonic, the other has to be what? Hypotonic. That is the first one. The second mark, you should make sure that gaining or losing of the water through the process of what? Osmosis. The process should be there. Is that clear? And we are saying it's either gain or loss of water. Then the third mark is what you are talking in your observation. Is that clear? So if your observation is right, it means you don't get the third mark. Is that clear? Yes. Let's now understand here. Which one is our first? I've said the first thing is what? Nature of the solution. Can you give me the nature of the solution?
The distilled water is hypotonic.
Distilled water is hypotonic. Then?
Is
you have to keep all the solutions.
Hypotonic to the salt solution, which
we are using a sugar solution today. So it's sugar solution being what?
Hypertonic.
So we're thinking about your sugar solution is hypertonic. 2. Distilled what? You get your first mark. Hope you understand this what I'm saying. I've said sugar solution is hypertonic to distilled water. What do I mean? If this one is hypertonic, distilled water is hypotonic. Is that clear? We just write off. Sugar solution is hypertonic, wine. Distilled water is what? Hypotonic. Is that clear? You get your first one mark. Then you go to that hypertonic section and you speak about exerting high osmotic pressure. An hypertonic solution always will exert what? High osmotic pressure. So we are saying what? Sugar solution being what? Hypertonic exerts what? I think it will do what? Exerts high osmotic pressure. Is that clear? When it exerts this osmotic pressure, it will do what? It will gain. I was saying it's either we gain or we lose. Is that clear? So what are we happening here? It gains water through arsenic what? Arsenic permeable membrane, that is tubing. By which process?
Osmosis.
By osmosis. That process should be there. You get your second mark. Is that clear?
Yes.
I'll say now leading to. I'll say now that mark will be observations that are there, right? Leading to what now? Visking tubing doing what? Tubing increase in volume, right? And we do what? And swell. While water volume in the digger decreases. And that is those explanations that you are supposed to explain. Exactly. So we are saying, number one, identify the energy of the solution. Number two, you should mention that hypertonic area or solution. Can you hear this? It will do what? And that is why I prefer for a student to start from the hypertonic to the hypotonic. Is that clear?
Yes.
No, we are not there. We are saying what? The solution. And we are saying this one being hypertonic. Start with hypertonic, not hypotonic, so that you speak about that hypertonic solution. Exerts high osmotic pressure. Drawing water through what? As an impermeable membrane. By the process of what? Osmosis, leading to your observation. Let me reverse the question here. Right? You have another visking tubing there. You have to now distill water inside the visking tubing. Distill what?
Water.
Then outside here, I can use a salt what? Solution. Let me hear. If you have understood. Who will explain? Identify the physiological process.
A salt solution. Osmosis.
Osmosis still, right?
Yes.
Observation.
There will be decrease in the level of the distilled water in the visking tube.
The level of the distilled water in the visking tubing will do what?
Decrease.
Will decrease. You make first is that beast. When you are making this one, ensure that the visking tubing is very touchy. Touchy means ensure you are filling with water, right? After some time, that visking tubing will become what? It will lose water. And when it loses the water, what will happen? It will shrink. That one we said it becomes what? It was increasing in size and becoming turgid, right? This other one will shrink. So solution is hyper or hypo?
Hyper. Hypertonic.
I'll say just to check from this point there. Where we have distilled water should be your hypotonic. Definitely. The other one should be the opposite.
Hypertonic.
Hypertonic. Is that clear? So if the hypertonic, the water is hypotonic. So what happens? Next point, so you have got your first mark.
Yes.
Second explanation is which one? Yes. Hey.
Or the sugar solution, the salt solution, being hypertonic,
Being hypertonic,
exerts high osmotic
it
pressure,
will exert high osmotic pressure.
hence gaining water, hence
Yeah, it's drawing.
drawing water
Or even gaining, it's still fine. It
Gain.
gains what? Water
through the semi-permeable membrane,
through a semi-permeable membrane
through osmosis,
by a process of osmosis. Second one. Leading to
the vein tubing's volume decreasing.
the volume of the vein tubing decrease and becomes and shrink.
Yes.
While
the salt solution in the beaker increases.
salt solution volume increases. That is it, right? So we are done with the experiment of what? Distilled water is hypotonic. Where we just have water, it should be hypotonic. Is that clear? Any water should be hypotonic. Is that clear? Let's use a second experiment. We are using a plant seltzer. A plant what? A plant material. A plant what? In lab. That was KCSE last year. It was a KCSE what? Last year. Of which the KCSE last year, what they were given is a skuma wiki. They were given what? Skuma wiki petiole. You know skuma wiki? It's a head. Which one is a petiole? A skuma wiki. Which one is a petiole? It's not a skuma wiki. Then now this one is our petiole. This upper section where we extracted from the stem, right?
Yes.
So they were told to cut that sample of a section. Then now this one we can perform various experiments. I said we can perform first experiment of a slit. We can perform an experiment of a lengthwise. And we can perform an experiment of what? A slit, the length, and the curvature. Is that clear? So when you speak about the slits, that was KCSE last year, it was for slit. Is that clear? Slit is, let's say this one is 6 centimeters. 6 centimeters. Then you are being informed, make a slit. Just to cut a section within the middle. Half section within 3 centimeters. So it's 6 centimeter length. You divide it halfway, but what? To a 3 centimeter length. So it means you have divided halfway, right? Yes. So you will have formed a split between these two. And with this split now, you make two. One to insert in a distilled water, again another one within a hypertonic solution. Right? That's the first one. We have another second experiment. We are just told cut this length, which is 6 centimeters and 6 centimeters, right? You have in two. One again in distilled water, one in what? An hypertonic solution, right? Like that, if you make a complete half. So you cut the split, so you have just one. You split into two halves, right? Those two halves you do. You insert one in distilled water, one in hypertonic. Is that clear? Then now we check your observation. Explanation will be just the same. Explanation will be the same. Observations are the other things. Is that clear? Yes. Let's start with the first experiment. The third experiment of what? A slit. Let's start with an experiment of what? You understand what I've said in a slit? Yes. I've said you check maybe a 6 centimeter length. 6 what?
Centimeter length.
Centimeter length of a page. Then from this 6 centimeter length, you make two. We have two pieces of those petioles of 6 centimeter length. Is that clear?
Yes.
Then you do what? You make a slit in both. So our slit is that way, right? So slit of what? 3 centimeter slit. Is that clear? Yes. You have another second experiment, the same thing. Make again slit of 3 what? Centimeter. Then from this slit, you dip it into what?
You dip it in hypertonic.
You have a bigger here. You have a second bigger, right? You figure A and B. At A, let's place what? At A.
Water.
Let's say water. Here is what? Water. Then this one for the second one it will be?
Glucose.
We can use glucose, right? We can use what? Glucose is a simple sugar, right?
Yes.
Glucose is a simple sugar. Then now, on these two experiments, we dip our two, we are dipping what? Our two, the first slit. The first what? Slit. The first slit. And the second one again, we dip what? Our second plant with a slit. The first question is usual. What would be our first question?
What is a physiological process?
Identify the physiological process. Identify what?
The physiological
The
process.
physiological process. Physiological what? Which one would be our physiological process?
Osmosis.
Definitely it will be osmosis. Is that clear? It is osmosis. What should be our second question?
What was the observation made in?
Observation. Our second question should be observation. After how many minutes?
30.
We do osmosis experiment for at least 30 minutes. So we are saying observation after 30 minutes. After what?
30 minutes.
30 minutes. Who will give me the observation? Who will try to give me the observation?
In A, it will decrease. It will increase in size and become turgid.
Trial. Here we are not speaking about length difference. Our answer should be based on slit opening, slit closing. I'll say this what? Either the slit opening or the slit closing. What will it do? The first one. Will the first one gain water or lose water? You should understand, when we place something in water, it will gain the water. Is that clear?
Yes.
When we put in another solution which is not water, it will lose water. So if you place in hypotonic solution, it will do what? Gain the water by osmosis. If you place in hypotonic solution, that water from the cells should be lost. Is that clear?
Yes.
So this one will gain water. If it gains water, what will happen to those cells? They will become turgid. When they will become turgid, what will happen? Will it open or close?
To Lopez.
It will open. So the cells are becoming turgid.
Yes.
Turgid. So it will go on extending. If it will be losing water, each cell will be losing water as it's closing. Is that clear? So we are saying this one will do what? And you are told you do what? You draw. They were drawing after the experiment. So the first drawing, let's do a drawing of this one. So I'm saying for A, drawing of A should be something of this kind. Let me draw it out. So you are told you draw for A and you draw for what? B. I'll say the first one will do what? Will open. Yes. So for the opening it will be something of this kind. Are you seeing the difference?
Yes.
The slit has done what?
Okay.
So we are saying slit opens. Slit does what? Then this other one. Slit does what? Closes. Slit closes, slit opens. Slit closes, slit opens. Right? So those are observations. So we are speaking about our observation. How do we explain the observation for the first one? It's this one. We are saying what? The slit will do what? Will open. And it's opening in which manner? Outwards. This other one is closing where? Inwards. So this one will open outwards. Is that clear? This will do what? Will. The slit, sorry. It's about what? The slit will do what? Close inwards. Are you learning? The slit will do what? Close inwards. It's a very important topic. If you don't understand, if you will be tested when your time of the exam comes, it will be there in always in most of the exams. KCSE, I don't know. If it will decide to come like last year, because kind of months, right? And it's experimental, you do it. Right now we are doing just the original, right?
Yes.
But for last year it was practical, so you perform it. When we have been saying, dip it in water, leave for 30 minutes, check your observation. You do it practically. It's clear. Yes. So those are your observations. Let's account for the observation. Account for what?
The observation.
Observation. Can you listen very carefully here? When you are accounting for a plant, when you are accounting for what? Definitely you know the other solution. Right here you know the first solution being what? Water is hypotonic. And this other solution you know that? Glucose is what? Hypertonic solution, right? So you know this first solution. So you don't know the solution of the other thing. And what are we speaking here? It's not a living tube. It's a plant cell, right? So from a plant cell, when we speak from a plant cell, you speak about plant cell. You remember the role of a cell? What was the role of a cell? In your common work, as an organelle, I think cell was an organelle, right? Part of a plant cell. You have the cell. What was the role of a cell? Storage of what? Sugars and what? Storage of what?
Sugars and salt.
Sugars and salts. So these sugars and salts can either become hypertonic or hypotonic, depending on the nature of the solution that it has been placed with. Do you get the point? Yes. So what you just speak, you have understood yours here. So you just tell me the plant cells that here will be. If this one is hypotonic, plant cells will be what? I don't know if you understand it. I'll say, if it's a plant, any kind of a plant, we will perform plant based on slit, curvature, each and every one. And I'm saying, you speak about plant cells. And I'll say plant cells can either be hypertonic or hypotonic. But now it will depend on the nature of the solution that it has. Is that clear? Right now, these are two plant cells that we have just cut from the sample. But now they are behaving differently because one will become hypertonic, the other one has to be hypotonic. Do you get the point? Yes. Because of the nature solution that we have placed the two. We have placed this on the water. This other one we have placed in what? Glucose. And you are telling me water is what? Hypotonic. So your cell shape should be opposite. If this one is hypo, this one should be what? Hypertonic. I get the point? Yes. The same way to this. This one is glucose. Which is what? Hypotonic solution. The cell shape should be
Hypo.
Is that clear? And now you apply what you have just been saying. So you come at this point, you tell me about the solution. We say the first match should be the solution, right? So the first match should be what? Cell shape is what? Cell shape is? Oh, in A. Sorry. That is in A. Let's account for A. Accounting for what? A. Account first for A. So for A, what do you speak about A? The cell shape is?
Hypertonic.
The cell shape is hypertonic. To what? To the water. You get your first one, man. If you understood how we were explaining, what was the second one? Big one.
The inner cell gained water.
No, that solution being hypertonic, it will do what? So the cell shape being hypertonic. Cell shape what?
Being hypertonic.
Being hypertonic will do what?
It will gain water.
Gaining is right. But for this student who needs to score an A, there should be some good biological terms that we use, right? So we are saying being hypertonic will do what? Exert what? Osmotic pressure. You see, the examiner can be tempted to tell you how does it gain water. If you have now this concept, you know it's the osmotic pressure that makes it gain. That's why don't speak the word osmotic pressure. That's clear. So it will gain what? It will gain. Oh, it will exert the high osmotic pressure, right? And do what? And gain what? Water or draw water. It's either gaining water or what? Drawing water. Through what? into a semi-permeable membrane. Semi what? Permeable membrane. Yes, next.
And become turgid and increase in
These are plant cells, this node of this king triple. A plant cell will just be directly to a semi-permeable membrane and you are done. This one is a plant cell. We have many cells within a plant cell. You can gain the water to the semi-permeable membrane. Then move from cell to cell by the process of membrane. Is that clear? Yes. Then what? Move from cell to cell by what? Osmosis. That is your second mark. Right?
Yes.
That is the second what? Mark. Leading to. I've said that that mark will be in your observation. Leading to what now? What's the observation in A? The slit, then what? Leading to slit opening outwards. Opening what? Outwards. Leading to the slit opening outwards. And the volume of water doing what? Is it increasing or decreasing? Yes? Volume of water does what? A decrease. Volume of water is doing what? Decreasing. No. Huh? It's doing what?
Decreasing.
Right. Yeah, you have lost the water. See, you have lost the water. If you lose, will it increase or decrease? It will decrease definitely. It will do what?
Decrease.
Decreasing. Is that now clear?
Yes.
Alright, let's go to the second.
Short about the point of the epidermis does not gain water because it is water absorbed.
For the epidermis, I'll not explain using this one. I'll use on the section for the slit, for the cavity. Is that clear? Okay. So we are saying what? We do for observation for B. No, we have said the observation for B, right? We are accounting for B. Account at what? Account for B. How do you account for B? I now need trial over here. The cells up. The cells up is what? Is hypotonic to. To what? What are we using here? Glucose solution. We are using what? Glucose solution. Glucose what? Correct. That is the first mark. You go to the hypertonic section. It's the hyper that exerts pressure. So it will be what now? The cells are big, hypertonic. It will exert high osmotic pressure, drawing water through a semi-permeable membrane. It's drawing. But the line even you are going, I think is right. If you speak about losing, you can speak about what?
Losing.
That the cells are losing water. Is that clear?
Yes.
But you can speak about this one is drawing water from. If it's drawing, it means the other one is losing. That is the same thing, right? When now it will have lost water, what will happen? The slit double. Oh, we are saying through the semi-permeable membrane. Or we speak, let's go with the one using. Is that clear? So it will allow what? The cells is hypotonic to the glucose solution, right? So glucose solution is hypertonic. So you speak about what? Being hypotonic. What will happen? The cells will start to lose water. Is that clear? And it will lose water from what? Cell to cell through a semi-permeable membrane by the process of what? Osmosis. Leading to the slit. Yeah, I think even that can be a good explanation. So we are saying what? The cells are being hypotonic. We are saying big what? Hypotonic. The cells will do what? Will lose. And you can check the spelling well. It's not LOSS. It's lose, right? It's lose what? Water. From what? Cell to cell through what? Semi what? Semi permeable membrane by what? Osmosis. You get your second mark. Leading to. What is it leading to? The slit closing and moving inwards. Is that clear? And moving what? Inwards. Is that clear? And the slit moving what? Inwards. Then what about the volume of the glucose? And the volume of glucose are what?
Increase.
The volume of glucose in the beaker.
Increase.
Increasing. That is it. And that is the end. Is that clear?
Yes.
Have you understood?
Yes.
Uh-huh.